All right, so today we're going to look at how to reduce a complicated circuit down to one resistor. This is also known as equivalent resistance. So, what I want to know is if I pulled out light bulb A, what other light bulbs would go out? So when I mean pull out, the circuit now would look like that. There'd be a gap. Does that make sense? Like broken. All the way. Okay. So, what other light bulbs would go out? Is everybody okay with B and C would also go out? Okay, here's a rule. Current cannot go two different ways in one wire. So you can't do this. You all right with that? Okay, so B and C would go out. If I pulled out light bulb B, what other light bulbs would go out? Nothing else would go out. Okay? It would still go through. If I pulled out light bulb C, what other light bulbs would go out? None. Still go through. Good with that? So, okay, so here's how we're going to do this. We're going to say that each light bulb had 2 ohms of resistance, and I'm going to find the total resistance or the equivalent resistance of this circuit. Okay? Now, if we pull out A, it affects everything. So you don't want to start there. Okay? If I pulled out B, nothing goes out. If I pull out C, nothing goes out. So we can conclude that B and C are wired in parallel. Put it in your pocket. Cell phone in the pocket. Disengaged. Completely. Thank you. So we can say these two are wired in parallel. You okay with that? So what we're going to do, we're going to say we're going to find the total resistance of those 2 light bulbs. The 1/2 plus the 1/2 gives you 2/2. Find the reciprocal 1. Okay? Now, you are going to fight me on this next thing. And you're like, it seems such a waste of paper. Why? I know where we're going. Okay? You wouldn't have to, I'm going to tell you to redraw the circuit. Okay? You don't necessarily need to redraw the circuit to get the answers for this worksheet that's due tomorrow. But lesson 6, the lesson after this is an essential skill. Okay? I'm giving you an opportunity to practice this essential skill. Okay? Redraw the circuit. So this is A, this is BC. This has resistance of 2 ohms, this now has a resistance of 1 ohm. I combine these 2 together, give me that one. Okay? Good with that? If I pulled out A, what else goes out? BC. If I pulled out BC, what else goes out? A goes out. I have to go through it and back home to make it turn on. Good with that? Okay? So these two are wired how? In series. So the total resistance in series, we just add them straight up, redraw. So A, B, C is 3 ohms. Now you're done. Okay? That's finding the total resistance of these 3 resistors wired this way is finding the equivalent resistance. Good with that? Okay? Any questions on this point? Okay. If I pull that A, what other light bulbs turn off? C turns off. You can't do, gotcha. That's not how that works. You have current going 2 different ways in one wire. Okay? If I pulled out C, what other light bulbs would go out? A would go out. This doesn't work. Okay? If I pulled out B, what other light bulbs would go out? None. It would still go. Okay? So, we can conclude that A affects C and C affects A, and only those two. So these two are wired in series. Good with that? So these two are wired in series. We add them together. That's 4 ohms. B. That's AC. Okay. If I pull that B, what other ones go out? None. If I pull out AC, which other ones go out? None. So B and AC are wired in parallel. So I'm going to go 1 over R is equal to 1 over 2 plus 1 over 4. That is equal to 3/4. So R is equal to 4/3. Good with that? Now, these were 2 easy examples. I'm going to go a little more complicated. Okay? These are like puzzles. You got to figure out how to take them. Okay? Questions here? Okay, I want you to go through, figure out if you pulled out each one, what other light bulbs would go out. Okay?
C, and if you pull out E, all of E,
It's like two series. One series is two plus two is two. Like six.
one over six.
Plus 1/4. Yeah.
That's like 1 over 10.
That ain't. But the fraction,
Okay. Pull out A, what goes out? All of them. Pull out B, what goes out? D. If I pull out C, what goes out? None. If I pull out D, what goes out? B goes out. You cannot do this. Is everybody good with that? Okay. If I pull out E, what goes out? All of them. So, here is a popular error. It's like, oh look, if I make 6 and 1, make them parallel. Okay? Because if I pull out this, that's not affected. If I pull out that, that's not affected. However, when I pull out 1, that affects something else. Do not condense something, do not simplify something if one of those affects something else outside of that simplification, outside of that grouping. Okay? So, I'm going to start with these two. Oh, you're kidding me. I'm going to start with these two wired in series. So the total resistance there is 3. So I'm going to redraw. Okay. Where I put this resistor, come on, you. Where I put this resistor does not matter. I could put it here, I could put it here. Anywhere along that branch is fine. Okay? So now, if I pulled out the 3, what else goes out? Nothing. If I pulled out the 6, what else goes out? Nothing. So those two are wired how? Parallel. Okay. So I'm going to simplify those. Parallel. So 1 over r is equal to 1 over 6 plus 1 over 3. That's equal to 2 6 plus 1 6 plus 2 6 is equal to 3 6. So r is equal to 2. Good? Redraw. 4 ohms, 2 ohms, 5 ohms. I pulled out the 4. Everything goes out. Pull out the 2. Everything goes out. If I pulled out the 5, everything goes out. So these three are wired series. They redraw. Good? Questions? Okay, as I pass out the rest of these Scantrons, these bubble sheets, I want you to strategize what your order of the groupings would be. For this one. That was an hourly.
Cause like I thought what I could. I'll just check this. Yeah.
So A and B A and B series, and then A and B is part of the so A, B, C is the series, and B, is the series. The rest are left in series.
All right, so in high school, I remember this problem. I missed this problem. They pull out A, what else goes out? B and C. I used to think that B and C stayed on because check this out. What's wrong with that thinking? We got current going two different ways in one wire. Okay? So, you're gonna do, so do not group it, sorry, this is not redrawing. Okay, I'm letting you know, like, don't do what I do right here. Series, yes? Okay? Now, here's a popular error. People go, oh, B, C, and D, E are wired in parallel. If I pull out B, nothing goes out. Pull out C, nothing goes out. If I pull out D, E, nothing goes out. Oh, they must be in parallel. However, if you pull out B and C, that's going to kill A. Does that make sense? So you need to deal with those two before you bring in this in. Okay? So these two are going to be wired in parallel. And then you're going to do A and BC series. And then finally, you're going to do ABC, DE wired in parallel. This is, I don't want you to do the circle thing. You need to redraw it. Okay? You'll be able to get the right answer for tonight's homework, not for the next homework. Okay? Good with that? All right. From the lab, please.